Hi, I'm Frank Stearns, president of Polk. Polk was founded in 1972 by 3 engineering students from Johns Hopkins University. They actually set out to produce public address speakers for bluegrass festivals, but the speakers were such a hit that consumers asked for speakers for their home. They founded the company on the premise that everybody deserves great sound and that great sound at great prices was a winning business formula. Clearly they were correct, because next year marks Polk's 50th anniversary. With more people than ever discovering the joys of home theater and 2-channel high-res audio, and with the adoption of Dolby Atmos, Matthew Polk's vision of accessible, high-performance sound is more relevant than ever. Over the next hour, we'll take you inside Polk's Acoustic Research and Development facility in Baltimore and walk you through how our engineers bring this vision to life with technologies such as our proprietary Pinnacle tweeter and turbine cone woofer. Let me now turn it over to Eric McBride to take you inside Polk.
Hello, and welcome to Inside Sound United. My name is Eric McBride, and I am the Premium Audio Brand Manager. And with me today, I have a special guest, Scott Orth, who's the Director of Audio and Acoustics for Polk Audio. How you doing, Scott?
Doing well.
Excellent. What can you tell us about this facility that some people may not know?
Well, like the name suggests, we do the audio and acoustic development here and also the research. So we're designing the loudspeakers. We house the engineers, mechanical engineers, transducer engineers, some electronic engineers. We also have the measurement facilities here to do work on loudspeakers. So this is where the product development happens.
So this is the brains of the operation.
That's right.
That's excellent. Cool. Now let's take a look at the Polk Reserve model lineup, starting with the stereo models. The versatile Polk R100 bookshelf features a 1-inch Pinnacle ring radiator tweeter and a 5-inch turbine mid-bass for dynamic sound in a small form factor. If you want deeper bass from your bookshelf, the Polk R200 features a 1-inch Pinnacle ring radiator tweeter and a 6.5-inch turbine mid-bass capable of playing as low as 51 Hz. If a floor standing unit is what you're looking for, then the Polk R500 is a great choice for music and cinema. The R500 features a 1-inch Pinnacle ring radiator tweeter and dual 5.25-inch turbine mid-bass, resulting in uncompromised cinematic sound. Moving up the line, we have the R600 featuring a 1-inch Pinnacle ring radiator tweeter and dual 6.5-inch turbine mid-bass for deeper and more accurate bass response. The PowerPort 2.0 featuring closed pipe absorbers called Export, cancel out internal resonances, resulting in higher resolution and detail. At the top of the range, you have the R700, the standard for uncompromised sound. The R700 features a 1-inch Pinnacle ring radiator tweeter and 6.5-inch turbine mid-range and dual 8-inch long throw bass drivers. The PowerPort 2.0, integrated with the dual 8-inch bass drivers, delivers tight, accurate bass response well below 40 Hz. For those interested in home theater, we offer a selection of center channels as well as a dedicated height module that can sit on top of the speaker or be mounted to the wall. Let's take a closer look into these models. The Polk R900 height module sits on to all floor standing models, allowing for immersive audio codecs to be played. The R900 features a 3/4-inch Pinnacle ring radiator tweeter and a 4-inch turbine cone. Looking for a compact center channel? The Polk R300 is the choice for you, measuring only 19 inches wide and 6.5 inches in height. The R300 features a 1-inch Pinnacle ring radiator and dual 5.25-inch turbine mid-bass drivers. This is a fully enclosed unit, eliminating any chance of port noise. If you want to flank your flat panel with an LCR array, look no further. The R350 is the perfect solution for you. The R350 features a 1-inch Pinnacle ring radiator tweeter and 4-inch turbine mid-bass drivers. The 4-way wall mounting system allows for horizontal and vertical orientation. Finally, we have the Polk R400, the largest center in our fleet, featuring a 1-inch Pinnacle ring radiator tweeter and dual 6.5-inch turbine bass drivers, delivering accurate bass down to 48 Hz. With the Export canceling any unwanted resonances within the chassis, this is the ultimate in center channels. So now that you have had a chance to see the Reserve lineup, let's talk about the key technologies that make Reserve special. Scott, what can you tell me about this Pinnacle tweeter? I keep hearing all about it.
So the Pinnacle tweeter is the third generation of the ring radiator. We've been using ring radiators since the early 2000s, started out in the LSI line. And this being the third generation, we've improved some of the things in it from the previous generation, one of which is the waveguide, which is where it gets its name, the Pinnacle waveguide. That improves off-axis dispersion and also can flatten out the very top end of the device. The other thing we did is we changed the dome. We found a new material that we liked a little bit better than that which we were using before. And lastly, there was a bit of a resonance caused in the cavity that exists behind the dome. And we did some research and found a way to get rid of that resonance.
That's excellent. Excellent. So when you talk about off-axis response, you're basically saying that it's not just about the sweet spot anymore, right? People that are sitting or standing, wherever the application might be, a little off-axis from the primary sweet spot, they're going to have a better overall experience.
Well, absolutely.
Yeah.
And it's always been something that's been a good quality of a tweeter is to have good dispersion, because not only is it about the direct sound that you get when you're sitting in the listening position, it's what's bouncing off the walls and coming to you. So to get a good immersive experience, you want to have good off-axis performance.
That's excellent. So I heard you say dispersion a few times. How do you measure dispersion? What kind of machine do you use?
Well, we have a couple of tools that we can use to measure dispersion. Our latest tool is a device called a near-field scanner. And what that does is it has a robotic system where we place the device on the machine, and then it rotates robotically around it, measures at many different points, and then it can actually create an entire dispersion pattern for that loudspeaker.
Almost like a polar response or something like that? Yeah,
that's exactly
very cool.
what it is.
That's excellent.
But in a balloon sense, not just a two-dimensional, a three-dimensional
wow.
system, yeah.
That's awesome. What can you tell me about this turbine cone? It looks very cool.
Yeah, so we spent a long time developing this driver. It's got quite a few different features. One that you'll notice right away is the what we call either bumps or the pedals of the cone, and those are there to control mode resonances in the cone itself. So a cone has natural frequencies that it likes to play more than others, and one of the things we have to do is suppress those. And so these features in there do that by stiffening up the cone in those directions. There's a couple of different ways it does this. One is that the modes that move outward and circularly from the center out to the surround, those are controlled by the curvature of the features. And then there's other modes that are actually like rocking modes that are back and forth that actually have the diameter, the line across the diameter, they rock back and forth across those. Those always happen in an even multiple, right? And so we've put 7 of the features in there to counteract that, so that there's an odd number fighting against the even numbers. So what it does, it takes all of the resonances that we would normally have trouble with and pushes them way out of band so that we don't have to worry about them anymore.
Right. And because it's a mid-range, we're dealing with very critical frequencies. So I'd have to imagine eliminating as many resonances as possible will result in cleaner, higher resolution, more detailed mid?
Absolutely.
Yeah, so now I see why you did it.
Yeah.
Makes sense.
We call it the critical mid-range.
Critical mid-range, I love it.
Yeah. So, and also the material itself is interesting. It's a foamed polypropylene. And the way that's constructed is in the machine, the injection machine, the material comes in and it's got foaming agents in it. So it goes into the machine and then the machine pops open just a little bit. And this foaming agent expands. So what you end up with is a skin on the surface, a hard skin on the top and the bottom, and in between it's a foam surface. So you get a very thick cone without the mass.
Wow.
And thickness gives you a lot of stiffness.
Yeah.
Yeah, so we used finite element analysis to help us design those features in there. In other words, we took a model of the cone in a computer and we iterated upon it until we found the best solution.
So the turbine cone is obviously a very key technology, but what is happening behind the scenes?
So we can talk a little bit about the motor structure. We used a T-pole, which ends up giving you a more even B field in it, which is the strength of the motor that the voice coil sees. And when you get that even, you get less distortion. We also added what are called flux control rings in it, which also reduces distortion caused by the fact that the voice coil is trying to demagnetize the magnet at all times. So we can control that a little bit better.
Very cool. So for the people out there that don't know what a motor system is, that is essentially pole piece, magnet. That's what controls the actual coil
stuff
itself.
that creates the force. That takes the electronic energy that's coming in and changes it into
that's pretty important stuff.
Into mechanical force. Yeah, it's critical.
So anything else you can tell us?
Sure. We've got what we call dual opposed spiders. So the spider is part of the suspension that allows the cone to move back and forth. And the spider has some inherent nonlinearities to it, which cause distortion. So one of the things we do is we put two of the spiders in opposing directions. So those nonlinearities tend to cancel themselves out.
So you mentioned the turbine cone, obviously all the stuff that's happening behind the scenes. What about this surround right here?
Right. So the surround is often overlooked, but it's also very critical in controlling cone modes. That the interface between the cone and the surround itself, we spend quite a bit of time getting that right, so that those modes that do come out from the center out to the edge are absorbed by the surround.
By the surround, yeah. So let's talk about the R700, the only true three-way design in the Reserve series. What are these woofers all about?
So the woofers have a lot of the same technologies we put into the mid-range and mid-basses. They have the dual opposed spiders. They have the flux control rings. They have a couple of other things that are different, though. One is the diaphragm itself, the cone, is what we call a catenary curve. And the catenary is basically the curve you get if you take a piece of string and the way gravity pulls on it. And the reason that's good is because it evens the force out across the entire cone. So that's one of the things that's interesting about it. The other is the motor design is a large overhung system to get lots of throw out of it.
Nice. And how deep do these go in terms of frequency?
Well, they go all the way down, but in this speaker, they get down into the 30s.
Wow, that's great.
Yeah.
In the Reserve line, you're using two types of ports, the power port and the export. What can you tell me about the power port?
Yeah, so in the R700 and R600, we have the power port, and the power port is an extension of the power port that we've always used, but we developed some new technologies, which is why we called it the power port 2.0. And that new technology is basically controlling the flares at the exit points of the port to get it a little bit less port noise.
Yeah, so that's called chuffing, right?
Chuffing, port noise, whatever you want to call it. You know.
Yeah. Okay, excellent. What about export?
So export's a brand new thing with the Reserve line, something we work quite a bit on. And the problem with ports is they're a pipe, right? And a pipe has resonances in it that it likes to play at, which is why pipe organs sound the way they do, right? So we need to suppress those. And usually the larger the port you have, the louder those resonances are. So the more important it becomes to have these resonances controlled. And since we have fairly large ports in Polk because we like bass, we developed this technology to suppress those resonances. And the way they work is they're a pair of quarter wave resonators that are situated inside the port itself that's tuned to those frequencies to absorb them.
So how do you even discover that? How do you even tune them? Is that a painful process, or?
It's partially trial and error, but there are equations that get you close. But like many things, we have to kind of shave it to the right frequency.
That's very cool.
Yeah, so one of the boons we have in this age is the rapid prototyping or 3D printing. So we can print a bunch of these parts and try them over and over, and change them slightly and try a new one and get to where we need to be quickly. Otherwise, we'd be whittling away with cardboard tubes and things like that, which we do anyway. But once we get close to what we want, we can go to the real thing.
That's excellent. I understand that you are the crossover guru. What can you tell me about the crossover in the development process?
Well, that's the big part of the tuning process, is deciding what crossover we're going to use. And our philosophy in general is to use as few parts as possible to get the goals we're looking for. And those goals, there are performance goals, there are cost goals, there are quality goals. And so we have to spend time looking at each individual part, deciding what quality it should be, not only the value that it needs to be, but are we putting the money in the right place, right? If we spend $50 on a really nice cap, and then the rest of it's junk, do we do the right thing? So it's all about this balance of getting to where we need to be with the right value.
Yeah. So yesterday when we were going through the tour, I saw something that looked like a breadboard, and it had all kinds of connections to it, inductors, capacitors. What is that?
So that's a prototyping system that we used, and it's been around since I've started working on loudspeakers. It's basically a board, wood board with a bunch of alligator clips that we can run leads to and from components. And
Right.
you know, while we're listening, we go and sit down and we take that board and we change part by part until we find what we like.
So topology is an important factor, right?
Yeah,
The layout.
topology, the layout. Yeah,
Yeah.
that's the order of the crossover, whether it's got EQ, notches, peaks, dips, all those kind of things.
So one of the things that stood out during the tour was you spoke about the inductors, how they couldn't be like parallel to one another. Can you explain that whole thing?
So inductors are electromagnetic devices.
Yeah.
So they spray out a field of magnetics, but they're also susceptible to magnetics. So when they're next to each other, they can interact with each other, and if you have to align their magnetic fields so that is minimized.
Wow, that's crazy.
Yeah.
It's awesome.
Plus, there's other things like if you have a resistor that gets hot, you don't want that next to your capacitor because it'll melt the capacitor or something like that. So
I've seen that before.
all that goes into play.
Yeah, that's wild. This cabinet is absolutely gorgeous. Now I see that has rounded edges. What is that all about?
So rounded edges are there to help reduce cabinet diffraction, and diffraction is a phenomenon. If you think about let's say the tweeter, the sound that's emanating from the tweeter, it's not just a beam, right? It's more like a floodlight, right? So there's sound going everywhere. So the sound travels across the face of the cabinet, and when it reaches a discontinuity, like an edge, it will re-radiate. So it ends up being like a very small reflection. And if you round those corners over, you tend to damp out that.
Oh, wow.
And
that basically just makes it higher, again, clearer.
Clearer sound, especially in the higher frequencies.
Higher frequencies, that's super important.
Mm-hmm.
And what's going on inside?
Well, there's a lot going on in there. We've got a couple of things. We've got the bracing, the all-important bracing. And we designed that using a combination of experience, finite element modeling, and we do some laser vibrometry to make sure we've got everything we need. And with the R700, we also have the CRC technology, which works quite a bit like the export. It's got a quarter wave resonator inside the cabinet that absorbs a cabinet resonance that otherwise would be a problem. It would escape through the driver and through the port.
There's something interesting going on with the base of the loudspeaker. What can you tell us about it?
Yeah, so for the reserve line, we wanted to try to reduce the visual impact of the diffuser for the power port. So what we did is we made as thin a base as we possibly could and incorporate that into the bottom. So it still serves the purpose that we need for power port, but it gives you a little bit cleaner sight lines.
Better stability too?
The stability is due mainly to the outriggers, and they have good stability.
And the rubber feet and spikes come with it?
Rubber feet and spikes.
That's right. So you get great coupling as well.
Yeah.
That's excellent. When I think of Polk audio, SDA always comes to mind. What is SDA? Can you explain it?
Sure. SDA stands for stereo dimensional array. It's a technology that we developed in the mid-'80s and used in loudspeakers ever since then. And what it does in general, it's a crosstalk cancellation scheme. So we've got, if you look at, say, the L800, you've got two sets of tweeter and mid-range on it. One side is for the stereo, the other side we call the dimensional array. And what happens is if you've got a speaker over here, you've got sound that hits this ear, but then it also wraps around your head and hits this ear. So what we do is we send a signal from the opposite speaker to cancel out that sound that's coming around your head. And the result is that the speakers tend to kind of disappear and the imaging just blows up into a very wide, expansive experience.
And you use this technology in something else as well? In any other products?
Sure, we've been using it in soundbar for years. Yeah.
Okay. Mm-hmm. And so the purpose in the soundbar is just to give it a bigger, wider stage.
Right. I mean, in soundbar, you've got a little 3-foot wide thing in front of you, and with SDA, you can make it sound like a very large loudspeaker.
That's very cool.
I hope you enjoyed that peek under the hood at our ARAD facility in Baltimore. We are extremely excited about the future direction of Polk. I'm sure you have many questions based on what you saw today. Let me turn it over to Eric and Derek for live question and answer.
Hello, I hope you had a choice to enjoy that video taking you inside our acoustic facility in Baltimore. My name is Derek Everson. I'm the Brand Activation Manager for the Americas, and I'm going to be able to host a Q&A session today. Or let's say I'll answer the easy questions and I'll pass off the difficult questions to my best friend at work here, Mr. McBride. So we do have a couple of questions come in, so we're just going to kick it right off. So the first question here is the R900 has a 4-way keyhole mounting position in the back. Is that able to be used for a surround application?
Absolutely, 100%. Obviously, it's primarily a height topper, but it can be wall mounted as well using the included wall bracket, the keyhole system that he was talking about. It's just important that you remember that due to the angled baffle, positioning is going to be key. So you just want to make sure that you really think about that when it comes down to actually integrating that into your sound system.
Awesome. Yeah, that makes complete sense. So the next question we have is another difficult one, which is my favorite kind of questions here. So the next question is, can you explain the export technology a little bit?
Yeah, so export is obviously new. It is basically, it's one of Scott Orth's babies. He basically took what we know as the power port. And one of the things that we did was when we were testing the internal resonances of the cabinet, we noticed that every cabinet has one, right? So what we wanted to try to do was to tune into that specific frequency and diffuse it all together. So what we came up with was closed pipe absorbers, what it's called. So it almost looks like a cardboard tube, but it's not. And essentially what they did was they cut certain holes in different locations and added different types of insulation. And what that does is as the air's passing through the port, it cancels out those unwanted resonances. So the result is cleaner, deeper bass response.
Right. It's a great technology. When we got to spend some time with Scott and ARAD, he showed us all the prototyping, and it was really cool. You can tell a lot of thought went into it, and you can clearly see that with the great, deep bass, that fun sound that you expect from a Polk speaker.
Polk, yep.
All right, let's get into another one here. So another technical acoustic question, which is the reason you're here, right? So what is diffraction?
Diffraction. So diffraction is essentially, if you can imagine a transducer or a speaker, so tweeter, mid-range bass driver. When it disperses sound, it's not a concentrated beam. It's more of like a floodlight. And that sound travels across the front baffle of the loudspeaker. With traditional loudspeakers that have a sharp corner, when that sound hits that corner, it diffracts or scatters. And that scattering effect essentially smears the resolution and detail. So what you notice with a lot of speakers, just like the L800 here, we actually have a taper off of the corner and it's rounded as well. And the result is less diffraction, resulting in higher resolution and detail.
Right, makes complete sense.
Yep.
Another question that might be a little bit related to that is around the turbine cone. Right, it's amazing technology. Scott went into some detail on it, but can you speak to the real benefit of particularly kind of these little forms in it?
Yeah, so these forms, I believe they call it petals. And essentially, if you look at any type of cone structure, the weakest point of that cone is always going to be kind of dead centered within the cone. So that's where you get the most sing from the cone, and it's not necessarily in a good way. It's a resonance that we want to try and handle, to take down. So essentially what they did using finite element analysis, which is like a laser vibrometer, they basically measured the cone, figured out exactly where these resonances were happening, and then they inserted these petals that you see here. And what that does is it makes the cone lighter, and adds a little bit more mass to it, but not too much, so it's still lighter, and it's very fast and accurate, and it eliminates those resonances.
Right, great. Another question here that I could take is, what's the latest center channel from Polk? If literally the latest is we've just launched some new speakers very recently, but the big thing to consider is we have 4 lines at Polk. So depending on the performance that you're looking for, the price point, size, fit, and finish, you can choose from the Signature Elite, Monitor XT, Signature Elite, Polk Reserve, as well as our Legend series. So there's a lot of different options for a center channel. So you can really suit whichever one meets your price and application. All right. So we have another question here around some acoustics, around the benefit of kind of this point in the middle of the tweeter here. What does that actually do?
That pointy thing is what we call the shape guide. And at the end of the day, we pay a lot of attention to dispersion, right? Not only dispersion at the primary sweet spot, but off-axis dispersion as well. So what we try to do here is using this pointy thing called the shape guide is it creates a nice natural linear response with dispersion. So even people sitting off axis get that nice sound stage and nice image.
Yeah, and it does a great job. You know, when you listen to these speakers, they have amazing imaging. But like you said, that off-axis response is great because, you know, sometimes you watch movies and music alone, but sometimes you have friends and family around you as well, right? So if you have different seating position, that smooth response from a broader area will translate to a much better experience for everybody
100%.
Watching the system. All right. So kind of a Polk history question here, which I think is kind of cool. In the video, we showed that house in Baltimore where kind of Polk was founded.
Right.
You know, I heard a kind of a quick story around that house and kind of what they did there. You recall that?
Yeah. So essentially, I know I found this out a few months back, but you know, Matthew Polk and his buddies and everything, when they started the company, they were in that home, and basically the third floor is where they all slept. The second floor was where they did all the engineering. And then the first floor was where they actually built the product and shipped the product. So literally everything under one roof. And look where we are today. Right? Just absolutely incredible story.
So it sounds like it was an in-house operation.
Oh, yeah. A little bit of a fraternity.
Yeah. I mean, that's awesome. But it's a homegrown brand, right? It has a tremendous amount of followers that love that big, fun, you know, Polk sound. And it's always been really affordable, right? And it goes all the way back to its roots, right? So it's great sound at an affordable price. So this is actually, there you go. That's what you call a segue, my friend. This is a great question. Polk is known for a great value. So for yourself, you know, what specific model yourself best exudes good value?
All of them.
It's a tough question.
But yeah, I know it is. In all honesty, we recently did a training and where we featured the Monitor XT. Okay. I believe at $300. Yeah. Absolutely blew my mind. Absolutely blew my mind for a speaker that affordable with that type of output is truly remarkable. But I mean, again, even looking at something like this, the L800, which is the priciest of the Polk lineup, I've heard speakers that have 5 times as much as this. And I honestly think this sounds better than them. Seriously, 100%. It's an absolute beautiful product, very affordable, built very well. So I don't think you can go wrong. Really don't.
Right. For myself, you know, the reserve line stands out for me. You know, similar to Eric, you know, we got a lot of time listening to the speakers, comparing between, you know, multiple different brands, and the R900 is absolute, you know, strong, good, powerful, clean, fun speaker. And, you know, one of the consistent things about Polk that I think is pretty, you know, let's just call it pretty consistent, is if you listen to the speaker without looking at the price, and then you look at the price afterwards, people are always like, it costs what? Yeah. Right? It's the performance to value is there throughout the entire line, so you really can't go wrong. And that certainly plays into lower price points with sound bars and so forth. You know, the entry level product from the brand still benefits from the historic engineering and ARAD and all those acoustic, you know, developments that we've made over many years. We have another question here. This is a good question. So, are the cabinets in reserve ply or are they made out of MDF?
I believe these are made out of MDF. Mm-hmm. Yes. Yep. Well, this is the Legend, obviously, but the Reserve is MDF, so if you were to pick up one of those, you would feel it. It's very substantial. They've obviously, with the CRC technology that's built into it as well, it's very rigid, very inert. They paid a lot of attention to making that cabinet quieter. With the export, with the CRC technology, it really is something else. I highly, highly recommend, if you have not listened to a pair of Reserve speakers, to go and listen to them as soon as you can, because they are remarkable for the price, especially for the price.
Awesome. Yes. Great. So that's it for the Q&A. So we're going to thank everybody for attending today. And I couldn't sign off without giving a good plug to our amazing YouTube channel. Phil's put a tremendous amount of great content over time. So please, you know, subscribe to us at Sound United Training on YouTube for the latest and greatest with all of our new training information. Thank you once again, and enjoy.